Okay. Calculate the amount of A reached in 10 seconds. When okay. Initial concentration of A is 50 mole per liter. Please use the above formula and try to solve the question. Put the value appropriately and you will get the answer. Let me know when you are done. You people make notes, right?
Yes, sir.
Hmm. Done.
Yes, sir.
What answer did you
30,
got?
30 mole per liter.
Hmm?
30 moles per liter.
30 moles per liter. Amount of air reached in 10 seconds. So let's solve this question. Then you will try in the next question. Just apply the formula and we will get this 50 minus 2 into 10, which will be 30 moles. The constant, calculate the amount of air reached. So you have to what you have told, mole per liter. It's okay. Yeah, you can. That is also okay. No problem. Mole per liter or 30 molar, right?
Yes, sir.
Calculate the amount of air reached, remaining moles. Okay. Please solve this question. Done.
Sir, I got minus 20 moles.
Minus, how can you get minus?
I don't know, sir, because the initial concentration is not given, so I assume it's zero.
If the initial concentration of the reactant is zero, then how will the reaction take place?
So, sir, what is
See,
the initial?
see. Uh, uh, See, we have got. You have to find out the calculate the amount of A reached in 10 seconds.
Yeah,
Okay. So, like amount reached. See how we can find out by KTC. Upon looking this formula, this is the remaining concentration. This is the initial concentration, right?
yes, sir.
So what this is? This
Um,
has been exhausted, right?
yes, sir.
Already this has been gone from the initial concentration. That is why we are getting the remaining concentration of the reactant as this one, right?
Yes, sir.
So this is gone, and so this is the answer.
So it's just 20 moles.
uh,
Okay.
20 molar or 20 moles per liter.
Yes, sir.
Got it?
Yes, sir.
Hmm. Uh, Now we will go to this half life. Half life by definition means half life of a reaction represented by T half or T 50%. It can be represented like this. Very important point. Time taken for 50% completion of reaction. Okay. The reactant will be, will reduce to 50% of its size. The time which will it take to reach that point will be known as half life of the reaction. Okay.
Yes, sir.
So by definition, at T half, we will be getting A will become what? the remaining concentration will be the initial concentration of the reaction upon 2, right?
Yes, sir.
So this is the important point, and we upon applying this formula, the remaining concentration will be A naught upon 2. Okay, that is A naught minus KT, right? When we move this will become A naught upon 2. This will come here, and minus minus will be cancelled out. This will be KT, and finally T will be T. Here is T half, mm, which will be A naught upon 2K. Got it?
Yes, sir.
Hmm. So this is the important formula. You have to remember this formula. T half for zero order reaction is initial concentration upon 2K. Please note it down. Done.
Yes, sir.
Hmm. Now, similar is the T 100% means 100% of the reactant is exhausted. So it will be the definition will be time taken for 100% completion of reaction. Okay, obviously, right?
Yes, sir.
So when we apply in this formula, A is equal to concentration of A is equal to A naught minus KT. So the uh, this side, this is remaining concentration of A. So remaining, there is no remaining concentration of A because all have been exhausted. So this will be 0, A naught minus KT. So A naught upon K will be T 100%. Understood? There is nothing remaining left, na? That is why we have put it as 0. Okay, and by simple
Yes, sir.
calculation we will get this. So T half is A naught upon 2K, T 100% is A naught upon K. So we can say that T 100% is equal to 2 times of T half, right? Can we?
Yes, sir.
So this is the important thing. Please note it down. So here are some few examples of zero order reaction. Uh, you have to remember one to only, don't worry. This one is the most popular one, H2 plus Cl2 in presence of light, H nu. H nu means photon, it will give HCl. Then another is 2NH3 in presence of platinum, and high pressure is high, and high temperature also high. It will break into N2 plus 3H2. The ammonia will break into nitrogen and hydrogen. Okay, so this is a zero order reaction, means the first reaction which take place does not depend on the concentration of hydrogen or chlorine. The second reaction, the this is a zero order reaction, means the rate of reaction does not depend upon the concentration of ammonia, right?
Yes, sir.
This is the basic definition of zero order reaction. We are just using that definition, and we are revising also meantime. HI in presence of gold and high pressure, है ना? What will happen? This will break into hydrogen and iodine. HI is very highly acidic thing, more acidic than HCl. Then another example is this. Hot platinum, pressure high, 2N2 plus O2. Please note it down. Done?
No, sir, 1 second.
Mm. So next time will you do your homework, because means half of the chapter is complete.
Yes, sir. I'll try to do yesterday's homework as well.
Uh, and this thing, first order, and try to solve from first order and second order also. Sorry, zero order and first order also. And you people are having a revision exam also. Before that, if you will do, that will help in your exam also, and
Yes.
uh, in your other exams also. So this is a good opportunity. Done.
Yes, sir.
Hmm. Now see, we will draw some graphs. These are important graphs related to zero order reaction. Similar, we will study for the first order reaction also. We will end the class soon. Uh, just earlier because
Okay.
important topics are going on and you people are busy. One second. No, I will not give first order reaction because it is not completed in class. So you people got the syllabus,
For what, sir?
weekly exam.
Oh, 1 second, sir. I don't think so, sir.
Okay, okay,
No, we didn't get.
okay. So graph for zero order reaction. Let's see. First graph is this is the representation of zero order reaction, right? The rate of reaction.
Yes, sir.
Huh. So see, uh, we from this point we know that with the respect to concentration of reactant, rate of reaction is independent of it, right?
Yes, sir.
Hmm. So what we can say here is when we are drawing a rate of reaction versus concentration of A. So this is independent of it, right? So with the concentration of A, rate of reaction will not change. Got it?
Yes, sir.
Huh. Now we will be drawing uh, this one, which we have derived yesterday. A is equal to A naught. Concentration of A is equal to A naught minus KT. So here, what we will see, we will draw graph concentration of A versus time. This concentration of A is the remaining concentration of A, right? Remaining reactant. So, hello.
Yes, sir.
So initially the concentration of A was A naught, right?
Yes, sir.
So initially concentration of A was A naught. Will it go, you know, upper side or below side? The
Lower side.
lower side. Why? Because concentration of A will
It's a
decrease.
prime. Yes.
Remaining will decrease, and it will reach ultimately to zero, right?
Yes, sir.
Uh, See, this one is we have put this in y-axis, so this is like y is equal to mx minus c graph. Okay, a straight
Yes.
line graph. So a straight line graph, for a straight line graph, the slope it will fall in this direction. Okay, this is straight line. Assume it. Wait, let me draw. So this is straight line graph. It will be like this. Okay, what is
Yes.
its slope? Oh, sorry, a second. Y is equal to c minus mx. Okay, so the slope is minus k, right?
Yes, sir.
Slope is minus k. Acha, one thing more, if slope is positive, then the line go like this. Okay, this is for positive slope, and if the slope is negative, then the graph will this will go like this in the left direction. Okay, so this is the proper graph of it. Okay, got it?
Yes, sir.
Finally, we have another t half is equal to a naught upon 2k, which we have derived it here. And for this graph, in this graph, you can understand that excellent t half versus a naught. T half versus a naught. This is directly proportional, right? Can you see? T half
Yes,
is
sir.
directly proportional to a naught, so it will go like this. Okay. At a is equal to a naught is equal to 0, t half will be 0. As it will increase, it will also increase. And the this is in this format, y is equal to mx. So m, the slope here will be 1 by 2k, right?
Yes, sir.
That is it. Understood all three graphs?
Yes, sir.
Uh, Done.
Yes, sir.
So you should have said now. Okay, no problem. Uh, let's go to first order reaction. First order reaction. So in this reaction, you know, it will be dependent on reactant. Rate of reaction will be dependent on reactant, right?
Yes, sir.
So here we can say R is equal to what? The rate of reaction will be equal to minus d upon dt. Obviously, in every cases, this one you have taught learned in first class, and also we know that the power of 1 denotes first order reaction. So we will equate both of them and we will solve like this. Then we will bring this here and send dt there this side, and we will integrate both side. Okay, so we will integrate both side. Okay, and we will continue. So dx upon x is ln x. Okay, dx upon x, if we integrate, it will become ln x. Okay, so here what it will become? Ln a. Okay, this is the integration rule. Do you know this rule?
Yes, sir.
Hmm. Where you apply these rule generally?
When you have to like calculate the whole thing by a given small length element or something like
Ha.
that.
No, no. Practically, where you are using in physics or chemistry earlier?
Physics.
That's what I was asking. So lna, then this minus sign is will be this side. We'll be having minus k into t, and obviously in integration we get a c if this is not a definite integration. Then we put values at t is equal to 0. We know that a is the concentration of a is a naught. Concentration of a is a naught. Okay. Now, now putting the values ln a naught.
No, what's not.
Your mic is on.
Sorry, sir. My brother can.
No problem. Ln a naught will be is equal to c. After we are putting this in this equation, okay.
Yes,
Are you
sir.
getting this? So finally, when we put this c value here, we will be getting this minus kt. Then this is one of the formula. We can modify it also, like bringing this to this side. Ln a minus ln a naught is equal to ln ln a minus kt. Uh, then after solving this, means if we do this plus minus plus this side, so this will become ln a naught upon a, right? And we are getting kt here. Are you getting this?
Yes, sir.
So one formula, you can learn any formula. This formula is the main formula. Okay.
Yes, sir.
uh, एक second. Please, I'm coming in a minute.
Okay, sir.
So where were we? So ln is generally not means people don't remember ln thing. It is converted into log 10 base 10 thing, and we will be getting a naught upon a. Okay, is equal to kt. That is it. Note it down, and we will be ending class here for today, and we will
Okay.
continue for the next session. It will be good for everybody. I don't have to repeat everything. Let me know when you are done. Okay.
Yes, sir. I'm almost done. 1 second.
Okay. Have you done derivation in class in school?
Yes, sir. Sir, in math, right?
No, no. This derivation, chemical kinetics,
Oh, yes, sir.
because it can come. Okay, that is why what I was saying.